Download this code from codegive.com, link in the description below. Unraveling the bytearray.extend misleading error message, GitHub issue 115323. This tutorial delves into a specific, and often frustrating, issue reported on GitHub as issue 115323 concerning the bytearray.extend method in Python and a misleading error message it can produce. We'll explore the issue, understand the root cause, provide code examples to reproduce the error, and most importantly, offer solutions and best practices to avoid this pitfall. Understanding the problem, the expected an object with the buffer protocol error. The error message itself is usually something like or. This error is triggered when you try to extend a byte array with an iterable whose elements are not integers in the range 0 to 255. While the byte array constructor allows you to build a byte array from strings, encoding them into bytes, the extend method is far more strict. It only accepts iterables that yield integers representing byte values. The misleading part comes from the fact that you might be trying to extend the byte array with what you think are valid byte values, example a list of integers, but the code has introduced a subtle error, or you're using an iterable that contains strings or elements outside the acceptable range for a byte. The error message doesn't directly point to the out-of-range value or the inappropriate data type, making debugging difficult. Why is bytearray.extend so picky? Byte array objects are designed for efficient in-place modification of byte data. The extend method is optimized to work with the raw bytes represented by integers in the 0 to 255 range. Allowing other data types, like strings or floating point numbers, would require implicit type conversions and checks, which would significantly impact performance. Reproducing the error, code examples. Here are several code examples demonstrating how this error can arise. 1. Extending with a list of strings ***. Explanation ***. This is the most common and direct way to reproduce the error. We're trying to extend the byte array with a list of strings. Bytearray.extend expects a sequence of integers, not strings. Python tries to interpret the string A as an index or buffer, leading to the buffer protocol error. 2. Extending with integers outside the 0 to 255 range ***. Explanation ***. This example attempts to extend with a list of integers, but one of the integers, 300, is outside the valid range for a byte, 0 to 255. While this raises a value error, it highlights the crucial point that all elements must be valid byte values. Sometimes, larger numbers can lead to other, less clear errors before the explicit value error occurs. 3. Extending with a list containing mixed types ***. Explanation ***. Here, the list contains both integers and a string. When extend encounters the string 20, it tries to interpret it as a buffer, leading to the type error. 4. A more subtle case, reading from a file, incorrectly. This example, while functional, can illustrate a different scenario. While it correctly converts each character of each line to its ASCII value, which is in the range 0 to 255, there's a more efficient way to read binary data directly into a byte array. If you were trying to read binary data from a file opened in text mode, you could unintentionally introduce errors if the data contained non-ASCII characters, values 127 when using the default encoding. To read binary data correctly, use the RB, read binary, mode. Explanation ***. RB mode * opening the file in RB mode ensures that the data is read as raw bytes. F.read, then returns a bytes object, which is directly compatible with bytearray.extend. *WB mode * similarly, the file is written in WB mode. 5. NumPy array with incorrect data type ***. Explanation *** Even though the array contains integers, the data type np.int32 is not directly compatible with bytearray.extend. Extend expects native Python integers, not NumPy's int32 type. You need to convert the NumPy array to a list of Python integers. Solutions and best practices. 1. Ensure correct data type ***. Verify the source of your data **. Double check that the data you're attempting to extend the byte array with is indeed a sequence of integers. Type conversion **. If necessary, explicitly convert the data to a list, or another iterable, of integers. 2. Validate integer range, 0 to 255. Filtering filter out any integers that are outside the valid range. Modifying modify the data to fit within the 0 to 255 range using modulo. 3. Read binary data correctly, file handling. Use RB mode * when reading binary data from files, always open the file in RB mode. This ensures that the data is read as raw bytes. *f.read, use f.read, to read the entire file content as a bytes object. This bytes object can then be directly used with bytearray.extend. 4. Handle NumPy arrays carefully ***. Convert to list ***. If you have a NumPy array, convert it to a list of Python integers before using bytearray.extend. Use np.uint8 data type ***. The most direct solution is to ensure your NumPy array has a data type of np.uint8, unsigned 8-bit integer, which directly corresponds to byte values. 5. Debugging techniques. Print statements before calling extend, print the data you're about to use. This will help you quickly identify if the data contains the expected values and types. Type checking use type, element, to check the type of each element in the iterable. IsInstance, use IsInstance, element, int, to confirm if an element is an integer. Assertions add assertions to your code to enforce that the data meets your expectations. Complete example with error handling. Here's a more robust example that incorporates error handling. In summary, the bytearray.extend error message is misleading because it doesn't explicitly state the cause of the problem. The error is typically caused by providing an iterable containing data that cannot be interpreted as byte values, integers in the range 0 to 255. By understanding the strict requirements of bytearray.extend, and implementing appropriate error handling and data validation techniques, you can avoid this common pitfall and work efficiently with byte array objects in Python. The key is always to ensure your input is a sequence of valid byte values.